Hello everyone, welcome to Coder and Boards. So in this video, we are going to discuss about the topic how to limit the number of requests from an IP address in Nginx, or we can say how to limit the number of requests coming from a source in Nginx. Okay, so this is a very powerful and important feature in Nginx, and this will be very useful for web developers. Okay, so let's get into the topic. So let me explain how it works. Okay, so let's say we have an API, okay, hosted behind an Nginx. So we have a proxy for this API, and we have this API accessed from several sources: source 1, source 2, source 3, source n. Okay, and the requirement is to limit the rate of request coming from each source to this API or a set of APIs. Okay, let's say my requirement is to limit from each source I want only 2 requests per minute, okay, or 1 request per hour, or 1 request per second. Okay, so if I want to do some rate restrictions, okay, so let's say like I mean in this API, let's say in this API or in this web service I have multiple APIs, so I can even define this limit at every endpoint within this web service. Okay, so what we need to do is we need to make some configuration changes in the Nginx so that Nginx will take care of doing the rate limit. Okay, so I'll explain the configuration and the advantage of enabling this kind of feature in the following slides. Okay, so now what's the need for this request limit? Okay, so this is, as I explained, this is very helpful for people who host APIs in the internet. Okay, so the first one is reduce unwanted request. Okay, let's say if you are exposing an API for a specific purpose, and in your depending upon the requirement, you may expect some number of requests from unique source. Okay, so if it is going beyond that, if somebody is making or abusing those API, so definitely this rate limit will help. Okay, so that is why like I'm reducing unwanted request. Then second is reduce the impact of attacks. So attack is something which is very common nowadays. So let's say if we have an API exposed in the internet, so these are the common attacks that we face. One is denial of service, distributed denial of service, brute force. Okay, so denial of service means the API will be there will be requests made to the API or the service multiple times, okay, from the same source, so at a very high rate. Okay, so what will happen, the API server will end up handling this heavy load from this source because of this kind of activity, and end up providing or end up going down. Okay, so that means the actual purpose of the API will not get served because it ended up spending all the resource in handling this kind of denial of service request, and finally the API will go down. Distributed denial of service means even a worse scenario of denial of service, so the same attack will be triggered from multiple sources. Okay, so the same attack, maybe like I mean the attacker will host the this vulnerable request sending source in multiple places, and that will hit the same API. Okay, so brute force means the username, password, or the authentication kind of APIs. They try and it's a kind of a trial and error method. They make various combination of username, password, try all these kind of combination and see which one works. Finally the permutation combination that makes the authentication success, right? So then using that they will enter into the application. So when we reduce the or reduce the request limit, or when we set the request limit, what will happen is all these will slow down. Okay, so that means the brute force also, the number of possible combination that they can try within a specific period of time will get reduced. Similarly denial of service also, so instead of serving the entire request, so because of this rate limit, the Nginx itself will reject those requests. Okay, so with all these things, finally what will happen, we will have an improved performance from the API. Okay, so these are the main advantages, or why we need this request limit. So I'll give an example scenario. Okay, so this is something I have used several times in the past. Okay, so I'm just giving an example scenario. So for example, let's say I have a requirement to collect data. Okay, I'm hosting an API to collect data from remote sensors which is located across the globe. Okay, and the method of sending this data is through REST API. So I have a REST API hosted in one of my servers, and I have hosted it behind an Nginx. Okay, so I have already assume like I have already shared the API documentation to all the client or the third-party software provider who is going to upload the data. Okay, so API is well defined, and any third-party software provider can refer to the API documentation and get the security credentials and make or push data to this API. Okay, data upload frequency 1 data point per sensor per minute. Okay, so okay, then think about like the scenario where we have several thousands of sensors located across the globe. Okay, the main problem here is need to restrict the request limit from each source to 1 request per minute. Okay, the reason why what's the reason? Because let's say if you are giving this kind of API definition to the people or to third-party software providers, it depends on how they write the program. Some providers, what they do, they don't care about like limiting the request 1 per minute. They just do it on a for loop or a while loop. Okay, so what will happen? It will keep sending data continuously. So in a minute itself there can be thousands of requests hitting our server. Okay, so which is kind of not a problem for them, because for them it is just one program, but for the centrally hosted API it's going to be a lot, because if every multiple vendors send request in this way, a lot of unwanted requests will hit the central platform, and finally the central platform's performance will degrade or the central platform itself will go down. Okay, so we need this kind of request limit, rate limit capability is very much required in this scenario. Okay, so the configuration for this, so let's get into the configuration. So the free version of Nginx supports this capability. It's not just the Nginx Plus, so the free version, the simple Nginx itself handles this capability. So what we need is we just need to add a couple of lines to the Nginx configuration. So the configuration details are given below. So the main thing is we need to define the zone, limit request zone. Okay, $binary remote address zone. Here we give the name API call limit. You can give any name. So this zone equal to is the zone name. Okay, colon a size. This is the zone size. So it's in MBs, and rate equal to number of requests per second or per minute or hour, month, week, year. All those you can define. R per S means rates per second, requests per second. Okay, so MB, this size is basically the zone size. I'll explain how to define the zone size. Okay, next part is limit request status equal to 429. So basically whenever the limit has reached, so the Nginx will start sending the status code as this one. We can update this to any number. Okay, any code. So then this need to be defined outside the server section. Okay, and inside the server section, inside the location, what you can do is so one more thing, we can define n number of zones in an Nginx. Okay, so there is no restriction, and we can have separate limits for separate paths or separate different virtual host within your Nginx. Okay, so let's say you have a login API and you have maybe data upload API. So for login API you can limit the request to some specific number, and for the data upload API you can limit the request to some specific number. Okay, so the way we use is internally within the path we need to refer the zone, limit request zone, okay, equal to the specific zone whatever we have defined over here. Okay, limit request, okay, zone. So this is for how we define the zone, limit request zone. Okay, and this is how we use the zone, limit request zone equal to what zone. Okay, then it accepts additional arguments like burst and burst with no delay. So this also I'll explain while getting into the practical session. So as I explained here, zone, while defining the zone we can define the zone size. So how to define the zone size? Okay, so zone size is it's defined in MB. Okay, so 1 MB means it can hold up to 16,000 unique IP. Okay, unique basically request from this unique IP, concurrent request from this unique IP. Okay, so that means let's say your API is handling 16,000 requests per second. Okay, so then that means you can define a zone of size 1 MB. But let's say if your web server is handling more than that, what you need to do, you need to do a calculation. So what calculation you will have to do? You'll have to do total number of requests, okay, divide basically total number of simultaneous connections from unique IPs divided by 16,000. Okay, so your zone size should be in MB should be greater than or equal to that number. Okay, total number of unique simultaneous requests divided by 16,000, that will give a number. So put that in MB or a higher value in MB to the zone. That will take care of the zone size. So this is the memory size that will be allocated for the zone. Okay, so as I explained, so the request can be defined in request per second, request per minute, request per hour, request per. So it's like, I mean, here I have explained per H means per hour, per day, per week, per month, per year. Similarly, R per S, request per second, R per M, request per small letter m. Okay, R slash small letter m will define request per minute. Okay, so you don't have to, like, I mean, do too much of calculation. You can use this keywords for writing the limit once in a year, once in a month, once in a week. So this number also you can change. Okay, let's say 2, 3, 4, 5, 50, 60, whatever number you want, you can keep it over there. Okay, now let's get into the practical session. So for our practical session, what we need an Nginx. Okay, so we need some web content. Okay, so I am using an API. So then for testing the request, so what I'm going to do is I'm going to use Apache Benchmark utility. So it is a utility within Apache utils. Okay, so this is available in Linux repositories. You can simply install using apt-get or yum install commands. Okay, so I'll show you how to install those utility. Okay, in case of Ubuntu, what you have to do is apt-get install Apache to utils. This will take care of installing the Apache Benchmark utility. Okay, so let's get into the machine. So I have Linux machine here, and I have Nginx configured here, and I have a Python program here. So this is a simple Flask REST API, so where it's just respond status equal to success on calling /API path. Okay, and if you see, it's going to run on port 8000. Okay, so let's test this API. So this is the IP address of the machine where I hosted the API. This is the port number, and this is the path. So this will hit the program directly, not through web server, but directly to the program. So let's hit this API. You see, status equal to success. So now in the Nginx /etc Nginx sites available, I'm using the default configuration. So as this is an example, okay, but you can use virtual host or specific configurations of your choice. So in this I have my Nginx configuration. So I have defined the request zone, okay, the zone, limit zone, and with the name API call limit, okay, 20 MB size, and rate restriction is 1 request per second. Okay, and as I explained, limit request status is 429. Okay, and within the server section I have a path that is /API. In the /API, what I'm doing, I'm going to use it limit request zone, then the zone name. So for now, what I'll do is I'll come in the burst related configuration. So what I'll do is I'll come in this configuration. So it will not use anything burst, but it will just use limit request zone equal to whatever zone I defined above. So you can have n number of zones with, you just need to change the name to specific. Okay, let's say you have /API one location, and you have another location /login. Okay, so /login you can define another rate. Okay, so that means depending upon the path, you can define any number of different rates. Okay, you can define different rates for virtual hosts as well. Okay, it's up to you. So let's test this scenario. So now if you see, it's limited at 1 request per second, and /API n equal to /API, it is proxied to the locally hosted API 192.168.1.148 8000 API. Okay, now let's make sure this configuration is loaded in Nginx. Okay, now let's see the benchmark tool. Okay, so the benchmark tool utility, it's, as I explained how to install this, it's basically apt-get install Apache to util. Okay, see, utils, Apache to utils. Okay, you can see package, all Apache to utils is already installed and the newest version, because I have already installed it. Okay, so the command is apt-get install Apache to utils. You can use any tool of your choice. I am just using this one. Okay, now let's see the command. Okay, so the command is ab-c for concurrent. Okay, how many concurrent requests you need to make, and -n is the total number of requests. So in this command, if you see, okay, in this command, if you see, it's making ab-c 300. Okay, let's clear the screen. Okay, so ab-c 300 request, concurrent request, total number of requests 10,000 to this particular API. So that's the requirement. Okay, 300 concurrent request, 10,000 totally. That means it will send 3 batches of 300 to this particular API. So here what we'll do is, let's clear the logs here. Okay, now no logs. Okay, and instead of hitting through with this through this Nginx, what I'm going to do is I'm going to hit the URL directly. Okay, URL directly means just this API. This is the URL of the locally hosted API itself, no Nginx in between. Okay, so we are bypassing and directly making the hit. See, it is hitting the Apache. You can see here 10,000 requests will hit here. Okay, 300, 300, 300. All the request response is 200. It's all happening. Okay, so it's taking a lot of time because it's able to handle only so many of requests per second, right? So now till now 4,000 requests handled, 5,000, 6,000. You can configure any number, okay, of your choice. 7,000, 8,000, 9,000. It's almost finished, done. 10,000. Okay, it took a total of 46.573. Okay, completed request 10,000, failed request 0. That means all the requests are served. Okay, the document path is /API. Okay, server software, if you see, this is like, I mean, I used the Python's the Flask default web server server. That's why, like, I mean, it is showing this particular server software. Okay, the IP port. Now what we'll do, let's modify the Apache configuration first, and there let's comment this configuration. Okay, so instead of, or maybe before commenting, let's use the configuration and see how it works. So here I'm going to use the same thing with the rate limit. Okay, in the previous scenario we saw every request was success. It took around 46 to 47 seconds. Now I'm going to do rate limit of 1 request per second. Okay, from the source. So I'm going to make these many number of requests. You see, 10,000, I mean 1,000. It completed. It finished very quickly. Okay, it took a total of 3 seconds to /API. It was hitting this machine's Nginx. Okay, and you see totally 10,000 requests went. Failed request is 9996. So that means only 9,996 requests failed. That means only 4 requests got succeeded. So why 4 requests got succeeded? So we set a rate limit of 1 request per second. So if you see 3.104 is greater than 3. So that means 4 requests will be allowed. Okay, so remaining all the requests were rejected. Okay, so in 3.104 seconds, only 4 requests from this source. What is the source? The machine where I requested from. Okay, from that source these many requests were allowed, rest all were blocked. Okay, now let's try disabling this configuration. Disabling this configuration means we don't have to comment the zone section. Zone is something that is already defined. Let's just comment this section, limit requests within the location. Okay, Okay, if I remove this part, what will happen? Let's refresh, reload the Nginx configuration, and let's make the call to the API, same API. Now there is no limit. See, it is taking time. Okay, so previously it finished in 3 seconds or 3.101 seconds or 3.1 seconds. Now you see it's taking a lot of time, right? Because internally in this one it's hitting a lot of times. Okay, that means the application behind the Nginx, it is getting a lot of requests, so this will impact the performance of this application if it is not intended. So in this much time it is only 6,000 requests. Okay, so that means half the request only served. Eight thousand, 9,000, 90% completed. Now the last 1,000 batch. Okay, it's almost finished. Looks like the API itself is stuck. Yeah, it's finished. Okay, so all 10,000 requests finished. Okay, and you see how much time it took? It took 83 seconds. Okay, so let's say if this was a requirement for one request per minute or something, what will happen? If the client is sending too many requests, it will end up degrading the performance of the web server, not the web server, maybe web server or API or application, or it will even bring down the application. Right now you see, so out of 10,000, okay, only one request failed, because it's basically because it was not able to handle the request. That's why one failed. It is not because of any other rate limit or anything. 999 got succeeded, one failed. Okay, and this is a failure, real failure. Okay, so it's not because of any denial or anything. The known 2xx response, you see 1. You can even see the logs from Nginx. Okay, where log Nginx error log. Okay, see the last error, you see connection timeout. Okay, upstream client, it is not able to give any response from the server. That means the web server was, the API server was stuck. Okay, the application got stuck because of too many requests. Okay, so that's the reason it did not get response within the time. There is a timeout. Okay, and in the access log, if you see, you will see almost the request for, you see Apache bench, the remaining successful request will be showing up over here. Okay, so this is how it works when we make the request. Okay, so rerun, I'm just rerunning it. Okay, now what we'll do is let's clear the logs. Now let's try another scenario. So in this way we checked with the limit, without limit. Now let's try with something called burst. Okay, so burst is a configuration that will allow an extended limit, okay, beyond the actual limit. Okay, so the reason for burst is, let's say in some scenarios, okay, so a specific source may need to hit additional number of requests beyond the actual limit. Okay, so this is kind of a allowance that we are giving. Okay, so in that scenario, what will happen? The burst, whatever the burst limit, whatever you are giving, that many requests on top of the default limit, right, will be allowed. But by default, what will happen? If you are simply specifying burst, then the 10 extended request that you are, or allowance that you are giving, that is going to go sequentially. It will go in a queue. Okay, so whatever you are defining here, 1 rate per second, this will be hit, or this will be addressed in parallel. Okay, these requests will be addressed in parallel, but from that specific source, and all these rate limit will be based on the source. Okay, a source IP address. Okay, so this will be applied, then that means it will accept, let's say if there are 100 different unique sources, then 100 requests will be handled per second. Okay, and this burst means burst 10 means along with this one, 10 additional will be handled, but it will be handled in sequential way. It will be in a queue and it will be processed one by one. So the performance of these additional 10 will be less. It will take some more time. Okay, so let's see how it works here. So this will be useful in case of like static content. So where the in let's say in a website, so some JavaScript the HTML contents or images or something need to get loaded, or in even in case of APIs, you wanted to give some extended limit in case of some specific type of request. Okay, so for all those kind of scenarios, you can give burst option. Okay, so by default it will be with delay. It means it will be going in a queue and it will be executing sequentially after the primary or the set rate. Okay, so let's validate the configuration. Nginx-t service Nginx reload. Okay, so let me verify the configuration once again. Okay, limit is there. Now let's do the benchmarking again. Now instead of allowing the 1 per second, you will see some more, maybe a 10 or something above the actual number you will see in this case. See, it took 13.011 seconds and 10,000 requests was sent. Failed request is 9986. That means 14 were allowed to go in. Okay, so but it took 13 seconds. The reason why? What's the reason? Because there were in the initial request time period, right? So the initial request time period. Okay, so it sent the primary, whatever the initial request went in, and along with that the buffer or the burstable limit, right? As part of burstable limit, some additional requests also went inside. Maybe the normal request might have completed in 3+ seconds, and an addition of 10 requests also went in. Okay, and that might have gone sequentially one by one. That's the reason here if you see 9986 request, even if with one request per second, 14 were allowed in this limit. Okay, and it took a total of 13.011 seconds to complete all these. The reason was to finish the burstable was going in sequence. Okay, so there is a different mechanism where we can set burstable or configure burstable in a different way without delay. Okay, right now what we have seen is the burstable or the burst option with delay. Without delay means it will almost function like the normal rate limit. Okay, so if you are specifying no delay, so whatever is there in the burst section, right, so this will get executed in parallel. Okay, so that means in effect what will happen, so you have one and on top of that you will get 10 more. Okay, so this is like the allowance that we get. Okay, and this as there is no delay, it will go in parallel, so you won't see much delay in processing. So the request, ideally the total time for finishing all the requests will be less compared to what we have seen before. Okay, so let's run the benchmark test again without delay. Yes, it finished very quickly. It took only 3.058 seconds. And how many requests it handled? So out of 10,000, same 14 requests were allowed to go in, and time taken was 3.058. Okay, in previous scenario it was 13.00011. Okay, so almost 10-second difference. Okay, the reason was because of the no delay argument. Okay, I hope this examples whatever I have explained in this video is clear. Okay, so if you have any questions or feedback regarding this video, feel free to comment below this video. Okay, and one more thing, once again, if you are hosting an API in the internet, okay, always set the rate limit based on the definition of or the requirement. Okay, so never keep it open or unlimited hits kind of thing, because attackers will there is a high chance that attackers may attack your API. Okay, so thank you very much for watching this video.